Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to talk about OCR, which stands for Optical Character Recognition, and we're going to use Python in combination with Tesseract in order to extract text from images. So we're going to take images that contain some text on the side, maybe on street signs, and we're going to take images that contain mainly text, and then we're going to use OCR in order to extract the text from the images. And for this, the first thing we need to do is we need to install Tesseract. It's an open source OCR engine, and you can find it on github.com/tesseract-ocr/tesseract. And in here, you can scroll down to installing Tesseract, and you can go to install Tesseract via pre-built binary package if you want to do that. And if you click on this, you can scroll down, where is it? Down here to Ubuntu, Debian, Windows. And you can, if you're on Windows, click just Windows Tesseract at UB Mannheim. And then you're going to get an installer for Windows here by just clicking on the 64-bit, for example, downloading it, running it. I'm not going to do that right now because I already have Tesseract installed. Now, the important thing that you need to do here is when you install it, look at the directory it is going to be installed in and add this directory to the path. So in my case, I'm not sure where it was, Tesseract. Let's just open the file location of the uninstaller. Open file location. There you go. So we have this Tesseract OCR. This is the location in my case. So for me, it's C program files tesseract-ocr. What we want to do is you want to go to the environment variables. So you want to go to edit the system environment variables, and you want to click here on environment variables. You want to go to the path. You want to edit the path, and you want to add a new entry with C program files tesseract-ocr. And what you also want to do is you want to add a variable here called test data underscore prefix, and this is going to be the test data directory. So inside of the Tesseract OCR directory, you have this test data directory here, and in here you can download the languages. So by default, I think you only have English. You can download the trained data files from the GitHub repository. So for example, here I have the German one, if you're interested in having multiple languages, but in order to find them, you need to have this variable here. All right, so that's basically the Tesseract installation. What you also need, of course, is you need PyTesseract, because Tesseract is not a Python module. Tesseract is the engine, and if you want to use it in Python, you have to install PyTesseract. So you open up the command line and you say pip install PyTesseract, like that. And of course, you can also, I think, install Tesseract here directly, but for some reason it doesn't work as well for me. So I would recommend installing it from the installer and adding it to path and then just using PyTesseract. Now, before we go into any of the Python code, we're going to do everything manually with Tesseract in the command line so that you see how this basically works. And for this, I have a bunch of images here. For example, here I have a basic image containing some text. Let me just see if I'm not blocking it. Not really, so I can leave it like that. It's basically just a text with, just an image with basic text. But of course, we cannot select this. This is still an image. We cannot just say copy and paste this text. It is still part of an image. In order to extract it, this is, of course, a very easy thing, a very easy task. We can use Tesseract. For this, we're going to open up the command line, and we're going to navigate to the directory where this file is, whatever it is in your case. I have a shortcut here. And basically, I'm interested in this text.jpg file. Now, how do I do this? Very simple. Tesseract, then the image, so text.jpg, and then std out to print the result of the OCR extraction onto the command line. So by doing that, you can see here instructions, and I get the text here as a result. So this is a very simple thing because, of course, the image is quite straightforward. We have very well readable text. So let's take something that is not as easy, like logos, for example. Here we have a bunch of different words. Let me just see again if I'm blocking anything. Let me just make this a little bit smaller here. We can see different words here. We can see Sony, PayPal, Microsoft. Some of them should be recognized. In order to see if that works, we're just going to do the same thing, and we're going to apply this on logos.jpg. And this is going to be a little bit more messy, as you see. We can see here PayPal, Sony, Microsoft, Bosch. and so on, but then a lot of stuff that doesn't really make a lot of sense. We can see NVIDIA here. So it partly works, partly not, and this is the challenge of OCR. Because what we also have is we have certain settings that we can use, and for this I'm going to copy and paste something that I have prepared here. This is just information. So here you can see the so-called page segmentation modes, and we're going to talk about them briefly in a second. And we also have the so-called OCR engine modes that we can choose. So I'm not sure why here it is not green. Okay, let me just add some comment here in the top so that we have this in green. So here we have the page segmentation modes, and here we have the OCR engine modes, and we can combine these settings to get different results. And how do we do that? We basically call Tesseract, and then we specify the individual settings. So I can do again the same thing, and now I can say in the end dash dash and then PSM, which stands for page segmentation mode, and a number from this list. So I'm not even sure what's the default, to be honest, but basically you can see what they do. So 0 says orientation and script detection, OSD only. Then we have, for example, something like assume a single uniform block of text. This might be useful for an image like this. It doesn't make sense for an image like this because that is not a uniform block of text. That just doesn't make sense. Then we also have the same thing for vertically aligned. Basically, we're choosing a setting to say, okay, I give you this little hint that this image is basically just containing one uniform block of text, and this makes it easier for the algorithm or for the process to be done in a good way. And otherwise, here we have, for example, automatic page segmentation, find as much text as possible in no particular order. This is also possible. Maybe we're going to get better results with that. So let's apply to the logos again with PSM 11. And you can see that we get a little bit more. We can see Vodafone here. I think we didn't have Vodafone before, right? Yes, so it recognized something new here. It just finds more, and sometimes it finds even stuff that's not there. So that's, of course, a trade-off, and this is just something I wanted to show to you. We're not going to go through all the settings, but we can choose these PSMs, these page segmentation modes, to get better results if we know something. For example, if we know there's just one single word, then we're going to get that. Maybe we can try this on the logos to see how it fails. There you go, we get seats. Well, doesn't make a lot of sense, but this is what you get from the different modes. Then we also have the OCR engine modes, and here we basically decide what model is being used. For example, we can say neural nets or legacy engine. I'm not even sure what legacy engine means, but LSTM is long short-term memory, basically a recurrent neural network. You can choose the type of engine that we want to use, and you can combine it. If you want to use it, you basically say in addition to PSM, or also without PSM, dash dash OEM, OCR engine mode, and then 0 to 3. So for example, we can go with 3. We can go with 2. Couldn't load any languages. Okay, this failed for some reason. And this brings me also to the next point, by the way. We can also specify the language. So I can say dash L and choose DEU for German. And it's going to try to find like German words, but yeah, doesn't really make any difference in this case. So those are the basic settings. This is how you use Tesseract. By the way, just one thing that I want to show you here as well. You can use Tesseract, neural deer, there you go. You can use Tesseract also for saving into text files. So we can say Tesseract and then text.jpg and text.text. So this is going to save the result into text.text. So we can open this up, not here, here, and you can see that we have the result in a text file. So this is how you use Tesseract in the command line. All right, now let's go ahead and do all of this in Python. First of all, we're going to import PyTesseract that we installed before. We're going to also import pill.image, and we're going to import CV2. Now, if you don't have these libraries, you need to install via the command line. Pip install pillow and open cv-python, like that. Those are the two libraries here. And what we're going to do now is we're going to start by creating our config. So we're going to say my config equals and then R and a string, and we're going to say dash dash PSM and dash dash OEM, and now we can choose some numbers. Basically, for the first image, we're going to work with text.jpg, and for this, we're going to assume a single uniform block of text. So we're going to choose 6 as the PSM, and we're going to go with the default OEM 3 based on what is available. This is our config, and now we can use a simple function called image to string to get the text. So we're going to say text equals pytesseract.image to string, and we're going to pass here pill.image.open, and we're going to pass text.jpg, and as a config, we're going to pass my config. And then we can just print the text like this. So this is enough, and as a result, you can see we get the text that is stored in the image, that is part of the image. So that's a very simple thing, and for text JPEG it works obviously very well. We can go with logos.jpg now. Now for this, probably we should change the config because, well, it's not a single block of text. Still recognizes some of the names here, but which one would be the best? Let's see. Fully automatic page segmentation, single column of text of variable sizes, single, nothing single, probably sparse text. Yeah, I mean 11, we already tried this in the command line. I think 11 is good, I think 12 is good, and I think these automatic things are good as well. So we can try something like, let's try 3. I'm not sure 3 is going to work well. We can try it. And we're probably going to get at least better results than before. Not the best, but we get some pretty good. We get Microsoft, PayPal, Sony, Canon, Kenwood, Mobile, Boss, Oracle, Yahoo, Rolex. So let's try with 2. Can play around with that. Again, this is just playing around. You can try and see which one gives you the best results for what you try to do. What do we have here? We have a problem because this mode is not supported, I guess. So let's try 11 again. We already did this, but yeah. So let's see. There you go. We can see a lot of text here. All right, so let's try another image. Let's try the signs. Basically here we have, let me just see, am I blocking anything? No, okay. Here we basically have street signs where we have village, center, width, limit, Blandford, Spedisbury, whatever. We want to see if our model or if our OCR is going to be able to do that. So we're going to say signs.jpg, and for this we're going to try to find as much text as possible. So the same settings as before. We're going to run this. And what do we get? We get center, we get Upton, we get village, we get Spedisbury, we get Blandford, a bunch of different things. Yeah, that's basically it. But we don't get everything because, for example, we didn't get width, even though it was part. I think we also didn't get limit. Yeah, so we didn't get everything there. Again, we can play around with the different modes. But this is how you turn basic images or how you extract basic strings from images. Now what we can also do here is we can plot rectangles around the recognized characters so we can see which characters are recognized by the OCR and which are not. And for this, we're going to have to change the approach a little bit. So we're going to say image equals cv2imread. So we're going to use OpenCV instead of Pillow because we're going to draw the rectangles with OpenCV, and we're going to pass the file name. Let's start with a simple one, text.jpg, and then we're going to basically just extract the shape. So we're going to say shape, height, width, and channels equals cv2, or actually image.shape. Now I'm not even sure if we're going to need channels, so let's turn this into an underscore because I think it's just a return value that we don't need, even though I'm not sure about that. We're going to see later on. Yeah, so basically we get the height, the width of the image, and then we're going to convert this image to boxes using Pytesseract. So we're going to say boxes equals pytesseract.image to boxes. We're going to pass the image and the config, my config, and let's look at the result to see what we're actually working with. So we have boxes. Let's run this. And what you're going to see is that we have these individual boxes here. So let's scroll up, quite a lot of boxes. We have the individual characters and we have the coordinates. So those coordinates are basically the rectangle coordinates. So we have the upper left corner and the lower right corner. I don't know what the last parameter is, to be honest. So we're going to ignore it anyways. We don't really need it. And what we're going to do now is we're going to say for box in boxes dot split lines. So we have split lines. So we have the individual characters as a separate box. We're going to say box equals box dot split on spaces, on white spaces. And then we're going to say cv2, or actually image equals cv2 dot rectangle. We're going to pass image, and then we're going to pass here, for the rectangle function, we need to pass point 1, point 2, which means upper left corner, lower right corner, and then it's going to draw a rectangle. And here we need to have integer of box 1, not 0, because 0 is the actual letter. And then height minus integer of box 2, because the height is inverted. And then we're going to pass also the integer of box 3 and height minus integer of box 4. Then we also need to pass a color. Keep in mind here that we're working with a BGR color scheme in OpenCV, not with an RGB. So it's not red, green, blue. It's blue, green, red. So if you pass 255.0.0, you're going to get blue and not red. But we're going to pass 0, 255.0, which doesn't really matter because it's in the middle. So it's green. And then we're going to pass 2 in the end. And we're going to display this cv2 imshow image. So this string can be chosen. It's just a title. Doesn't matter how you name it. And then cv2 wait key delay of 0. So if we run this, we should be able to see the boxes. There you go. You can see the image and the boxes around the recognized characters. Now I think that this here is not actually a character, is it? Let's see. Where's the text? Where was this actually? Or was it li? Yeah, then it's li. It's just plotted above the characters. Okay, so this works very simply or very easily for this particular image. Now let's apply it to logos to see what it recognizes there. And we're going to see that it's not as good as on the other image, but it still recognizes quite a lot. So it sees, okay, this is recognized as 2 characters, so we see B and C, but not really the I. This is recognized as a character. We can see MasterCard being recognized as 2 characters, Samsung as 1 character, and maybe a lambda in here or an S. We can see that Sony works, PayPal works, Microsoft, Bosch works, Yahoo works, and so on. So partly it works, partly not. And now let's go to the actual signs. And we're going to see that there it doesn't work very well. At least it skips a lot, or it finds a lot that is not actually a character. So these 2 things are recognized. This one is recognized. I don't understand why this one is not recognized. Those 2 words here are also not recognized, but we see here that a bunch of leaves and a bunch of trees are recognized as characters. So this is not optimal. And of course you can also, let's go back to the logos. You can also see how the results change if you change the mode. So let's say we assume, well, let's change 11 to something like 2 or something like 3, for example. Let's change it to 3. We're going to see that the results are quite different there. Maybe not for 3 and 11. Oh, actually this looks a little bit better. Yeah, this actually looks way better than just using 11. But if we now say, okay, we assume a a uniform block of text. So let's go with 6. This is not going to work very well with the logos because it's not a uniform block of text, obviously. But actually, it still works quite good. So let's pick the worst option. Let's say it's a single word. So let's change this to 8. And then we're probably going to see very bad results, hopefully. Yeah, there you go. So if it thinks that all of this is a single word, you can see that the boxes are also not very well placed. So let's go back to 11. And what we can now do as well is we can go ahead and not only plot boxes around individual characters, but around individual words. So we want to say, okay, obviously, if we go to logos, we will see that certain characters belong together. So eBay will not be recognized as E, B, A, and Y. It will be recognized as one block and thus as eBay. And because of that, we want to plot boxes around the individual words, not just the individual characters. Now for this, what we're going to do is we're going to remove all of this here. And I think we can keep this CV2 imread stuff. Yeah, that should work. And then we're going to use a different function. We're going to use the function image to data. So data is going to be PyTesseract image to data. And we're going to pass the image. We're going to pass the config. And we're going to pass an output type. And for this, we're going to have to import something. We're going to have to import from PyTesseract import output. And we're going to choose output dot, and here you can see we can choose data frame, which is, I think, a pandas data frame. We can choose dictionary. We can choose byte, string, whatever. We're going to go with a dictionary for today's video. And then we're going to print the data in order to see what we have in there. Actually, let's just comment this out so we don't see anything. And you can see here we have a level and we have a bunch of values and then a bunch of more stuff. So maybe we should print the keys to see what we have in here. So the key should give us information about what we can actually extract. We have level, page num, block num, par num, line num, word num, left, top, width, height, conf, text. Conf is confidence, text is the actual text. And I think those are the things that we need for the plotting of the boxes. So let's go ahead and see what we have in data text so that we see how this library actually works. And there you go. You see all the recognized words. Okay, that's interesting. So what we're going to do now is we're going to say let's say amount of boxes is going to be length of data text. And then we're going to say for I in range amount boxes. And we're going to say if the float version of data confidence. So if the confidence is above a certain threshold, so let's say 80, for example, which is a confidence of 80%. If the confidence is as high, then we're going to plot a box, because otherwise, if we set the confidence too low, it's just going to plot boxes everywhere. So we're going to say if the confidence that this is a word is above 80, we're going to say x, y, width, and height are going to be data left, data, actually let's turn this into a tuple, data top. And of course we want to do this for each instance, so we need to provide I as well here as an index, then data, what was it, width, I, and data height, I. So we're basically getting the top left corner of the rectangle and then the size, and this is enough, of course, to derive the rectangle itself. And because of that, we're going to go into the next line and say image equals cv2.rectangle. We're going to plot onto the image, and the rectangle is going to start at x, y, and the lower right point is going to be x plus the width and y plus the height. And of course, don't forget the BGR color scheme again, 255 for green, and then 2 again And then what we're also going to do is we're going to put the text of the images or the recognized text below the boxes. Now, we can do it without as well. So then you will already see the boxes around the text. So if we run this, we will already see the result, at least if we didn't make any mistakes. Of course, we did some. Float argument must be a string or a number, not a list. I think we need to add an I here, right? There you go. There you go. So now you can see the recognized words: PayPal, Sony, HP, eBay, Microsoft, Bosch, Oracle, Boss, Philips, CK, Canon, and so on. But we don't see what the actual recognized text is, because maybe it makes some mistakes. Maybe it says CK is a word, but I see OK. So in order to see what it actually does, we're going to say cv2.put text onto the image. We're going to put the text, which is data text. We saw in the keys that we have this text key, and we're going to pick, of course, the ith one. And we're going to place this text below the box. So we're going to place it at x and y plus height plus a little bit more, 20 for example. We're going to choose the font cv2.font Hershey Simplex. We're going to pick a scale of 0.7. So we're going to make it a little bit smaller than the default. We're going to pick as a color 02550. We're going to pick 2 as a thickness, and we're going to pick the last parameters, which I forgot what it actually is for. I think it's optional, but I chose in my prepared code line 88. So that should be actually enough, and we can run this. Hopefully I didn't block anything. I don't think so. But there you can see now what it actually recognizes: Philips, CK, Bosch, Microsoft, PayPal, Sony, eBay. Here it recognized, I don't know what this is, O, or I don't know what it is, Canon, mobile, question mark for Burger King, GW for CNN, which is, you know, I can't understand this. This could also be a W. Yeah, so you can see what it actually does. Now, in the case that I block the code, this is the code. Let me just close this. This is the code. We're basically plotting a rectangle, and we're putting a text onto or below the box. So let's swap the image. Let's go with the signs to see if it works as well. Let's run this. And you see Blandford, Spetisbury, Upton, Village Center. Then it says LA in the trees here. I mean, this could be LA if you have a good imagination. And of course, we can also lower the confidence. So we can say, okay, if you are more than 20% confident, then show me more. And maybe we're going to get more text based on that. And you can see we get a lot more misclassifications, but not really anything useful. So we don't get any of these words just because we lowered the confidence, but we get a hey up here in the tree. So yeah, that's not really intelligent in this case. We can go to the logos though and see if that changes anything. So if we go to logos.jpg, run this again with a lower confidence threshold. Yeah, we can see way more, but not necessarily correct stuff. So Adidas is AS. Then we have YouTube WID. So yeah, it's not really a good thing. But NVIDIA was classified. I think NVIDIA was not recognized with a threshold of 80. But yeah, you can play around with the settings here. This is how you do OCR in Python. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.